Hello everybody, it's Mr. Stone here to help you with applications involving right triangles. Let's go ahead and take a look at some useful tips before we actually see some applications. Now, as far as solving a right triangle is concerned, here's our right triangle. We're given angles A, B, and C, and sides little a, little b, and little c. Alright, well, first useful tip I have for you is the Pythagorean theorem. Remind you, a squared plus b squared is equal to c squared. Secondly, keep in mind that when you add all the angles within a triangle, they have to equate to 180 degrees. Well, with those guys in mind, let's go ahead and take a look at our first example. We're given angles A, B, and C, where angle A has a measure of 50 degrees. Side A, however, is 6 units long. What we want to know is the length of B and the length of side C and the measure of angle B. Fair enough. Well, what do we know from the given triangle here? We know that the measure of angle A is 50 degrees, and the measure of angle C, our right angle, is 90 degrees by definition. So, to find the measure of angle B, what you're going to do is take 180 degrees, which is the total of all the measure of the angles of the triangle, subtract from that the sum of the measure of angle A and the measure of angle C. That gives you 180 minus 50 plus 90, or that the measure of angle B is equal to 40 degrees. Beautiful. Now what do we got to do? We have to find sides B and C. Alright, we have our angle here, angle A, and we have a side opposite of angle A, that's little a, and we have the adjacent side, B. Now if you remember SOHCAHTOA, that refers to our tangent. Opposite over adjacent, so hence I have tangent of A equaling A over B. And then you can plug in what you know to solve for side B. Now there's an alternate solution where you could have done sine of A. Sine of A is equal to opposite over hypotenuse. That would be A over C. If you'd chosen to take that path, then you would have solved for side C, then you would have had to find side B. But this way, we have tangent of 50 equaling 6 over B. So we're finding side B first. Now B ends up being about 5.03 units long. Now that we have that, we can go ahead and use the Pythagorean theorem, c squared equaling a squared plus b squared, to find side C. Knowing that A is 6 units long, and knowing that B we just computed to be 5.03 units long, how would you find side C using the Pythagorean theorem? Welcome back, folks. Alright, let's go ahead and finish up this problem here. What do we got? We have c squared equaling a squared, or 6 squared, plus b squared, 5.03 quantity squared. That gives you c squared is equal to 61.3. Now, if you were to take the radical of both sides, you see that c is about 7.83 units long. Excellent job on that problem. Now we're ready to look at some terminology. We got here a person looking at the top of the building. This is called the line of sight. And here, of course, is the horizontal line. Now, between these two lines is created an angle, and that angle is referred to as the angle of elevation. As opposed to if you're standing on top of a building, looking at a person on the street, here's your line of sight. There's an angle created. That's known as the angle of depression. Alright, two things to keep in mind here. Now, let's take a look at an example that involves the angle of elevation. We have here a guy that is 300 feet away from a building, and our angle of elevation happens to be 35 degrees. Now, what we're interested in knowing is the height of the building. I'm going to go ahead and label this x, our unknown. Well, what are we given? We're given an angle, a side opposite that angle, and an adjacent side to that angle. So that refers to the tangent again here. We have opposite over adjacent, or the tangent of 35 degrees is equal to x over 300. Now, isolating the variable, I get that x is equal to 210.1. So, we're talking in terms of feet here, so the height of the building becomes 210.1 feet long. Excellent. Well, what if we had a problem that dealt with angle of depression? What do we got here? We have a man on a safari on top of a cliff. He spots a line. All right, we're about 126 inches away from the line. That is precisely 10.5 feet. Very close, so make sure we're not seen because we really don't want to be eaten. So the first time we spot it at its head, and that angle of depression is 79 degrees. I'm going to call that theta sub 1. Now secondly, when we see it again, we spot it at its tail, and this time the angle of depression happens to be 78.5 degrees. Now note, we are not moving, and neither is the lion. We just spotted it at two different points. So this length here is not changing. It's the same thing. I'm going to call those guys x's. Now what we're interested in knowing is the length of the lion. How long is the lion? Well, we're definitely going to figure that out right now. Notice here what we're given. We're given an angle, a side opposite that, and an adjacent side. So we have the tangent of our angle, of our first angle, happens to be x over 126. Isolating x, we get that x is equal to 648.2 inches. Now we got to do the same thing for our second angle here. So how would you set that up? Welcome back, folks. Alright, let's go ahead and take a look at the rest of the solution of this problem. We got the tangent of our second angle is equal to x over 126. That gives us 126 tangent of 78.5 equaling x. So that equals to 619.3 inches long. Alright, well what we have to do now is subtract the distance we found here, this guy, actually 619.3, from 648.2 to be left with the length of the lion. Now what we're going to do is end up with 28.9 inches. Or if the problem asks you to give your answer in feet, you would leave it in terms of feet, or you get 2.41. And there you have it. That is definitely your answer for the length of the lion. Good job on that one. Now I got one more example for you. And this time, we live in a house and we're elevated at 11,700 feet. Now 16,000 feet away from us exists a country club which we are going to tonight. And that is elevated, the country club, at 19,200 feet. Now what we're interested in knowing is the inclination of the path. So here's our angle that's being created, and what we need to know is another side here. We have an angle on one side. We can definitely find, I should say, the length of that side. Notice at this point we're at 19,200 feet, as opposed to our initial point where we're at 11,700 feet. Subtracting these two guys together from one another, we get the length of this guy. The inclination happens to be 7,500 feet, the difference of the 2 points. Now, what we need to do is see what we're dealing with here. We got an angle and two sides. This side is opposite of our angle, and we have the hypotenuse. So opposite over the hypotenuse refers to the sine function. Hence, the solution becomes as such. Sine of our angle is equal to 7,500 over 16,000. Alright, now this is approximately 0.46875. Taking the inverse sine of both sides, we see that our angle, our inclination of the path, is 27.95 degrees. And that is definitely our answer. Alright, ladies and gentlemen, that is all I have for you. If you have any questions, by all means go back to the beginning. Otherwise, make sure to have fun with these problems, and I hope to see you again.